Okay, hello ladies and gentlemen. Welcome back to New York for a presentation less plagued with technical difficulties, I hope. Please welcome David Giovanni on the stage with Kubernetes and CAPI Provider. Thank you, David.
All right, thanks guys. So I'm David. I'm going to give a talk on how we developed Kubernetes CAPI Provider for CloudStack. All right, a bit about me. I'm sure you were there for the last presentation, hopefully. Firstborn, favorite child. I keep telling myself that when I go to bed every night. I like sports, I play rugby. I'm committed to the Apache CloudStack project. I'm a member of the Kubernetes community and the Kubernetes SIG community. And I work as a developer here at ShapeBlue. All right, so let's have a quick rundown of what we plan to do today. So first thing, why did we come up with CAPI? I mean, CAPC, the provider for CloudStack. What is it? Maybe go a bit into depth if you missed it last session. How does it work? How we did it, our story, not how we coded, but how we interacted with the Kubernetes community and worked with them to bring out a product which customers can use in production. And I think we have customers or users who are using it in an environment with over 100,000, with over 10,000 hosts, and bring up multiple clusters spanning hundreds of nodes. And then finally, hopefully, a demo. All right, so let's start off about why we did it. So this was a collaboration between AWS and ShapeBlue. So they approached us and they were like, hey, you know what? This seems like a really good idea. This is something that people could use, that they could use in their environment, in their data center, in their on-prem environment. Why don't we look into collaborating and coming up with a product like this? So we were curious. We were like, hey, it sounds like a good idea. Let's go ahead. Let's see what it goes. And I'll get a bit more into depth into this once I cover the overall architecture. So I'll cover the architecture and then I'll get into the story of how we got into it. All right, so picking up from last presentation. So why do we have Cluster API Provider? So there are a whole bunch of cloud providers. You're on cloud, you're on-prem, OpenStack, GCP, CloudStack, AWS. But the problem with them is if you would like a Kubernetes offering from them, they're tailored services. They're customized to their particular product, to the particular infrastructure on which they're running. They have differing implementations. So let's say an upgrade that could, if you'd like to upgrade your Kubernetes versions, in one provider it would be an in-place upgrade. In another provider it would be a rolling upgrade. There's no standardization. They use custom distros. Each provider, like let's say a cloud provider like AWS uses the EKS-D distro of Kubernetes, right? And finally, you have to manage your clusters individually. You have to log into that provider's platform in order to manage your cluster. And if you have clusters ranging across all your providers, you'd have to manage them individually via that provider's portal. So they came up with a solution. Hey, you know what? This is causing a lot of problem. We don't want the hassle of dealing with all of this. We don't want the hassle of dealing with multiple providers. So they came up with CAPI, Cluster API Provider. So what does it aim to do? It aims to solve those problems. It aims to standardize it. So there's no more vendor lock-in. There's no more specific tailored services. It standardizes everything. So whatever you use on one cloud, you can expect the same behavior on another cloud. It provides default implementations. So like we said, during an upgrade, it could be a rolling upgrade. It could be an in-place upgrade. It standardizes it. It provides a default implementation. So if you have a CAPI cluster running on AWS, and an upgrade is a rolling upgrade, if it's running on CloudStack, you get the same behavior, a rolling upgrade. Then it provides commonality. So there are custom distros, right? And every cloud provider uses their own. But what it does is it provides commonality. It defines a suite of tests called conformance tests through which you can run to make sure that whatever version you're using is conformant to Kubernetes. And finally, it provides a unified cluster management. So all your clusters running everywhere, you can manage it from the management cluster. It provides a single pane of glass in order to manage all your clusters running wherever they are. All right, so you saw that it's a great product. It solves all these problems, right? How does it solve it? So first, it defines common operations. You know, the basic CRUD operations that you have: scale, upgrade, create, delete. Then it provides a default implementation, like we said. So it provides a default implementation to make sure that whatever you have runs the same everywhere. Then it uses a declarative approach. So Kubernetes provides a declarative way of defining your APIs, right? It uses that same declarative approach to define your Kubernetes cluster itself. And finally, it provides a tool called clusterctl through which you can manage all your CAPI clusters. It's a CLI tool. All right, so let's look at a high level of how it works. You define your cluster. Say, hey, you know what, CAPI? I like a cluster. I like it running in this infra. I want 3 control plane nodes. I want 5 worker nodes. Okay, great. I want it. Tell CAPI. What does CAPI do? CAPI says, okay, this guy wants it. Okay, now what do? He wants it. Oh, he wants it running on this particular cloud. Let me talk to that cloud provider. Cloud provider provides the interface through which CAPI will talk to your infrastructure and provision your Kubernetes cluster. So it'll talk to your provider. It'll say, deploy your VM, use this user data, bring it up. So it'll talk to provider. It's the provider's job to talk to your infrastructure. So it acts as an interface between CAPI and your infrastructure. And through it, it brings up your Kubernetes cluster running wherever you want. And now CAPC uses CAPI. So now your entire Kubernetes clusters can be powered by Apache CloudStack. They can run on your infra. All right, remember I told you about the cluster spec? So this is what it actually looks like. So don't be scared. It's all auto-generated. You don't have to worry about a thing. So you say, hey, I want a cluster. What's my underlying infrastructure? My infrastructure is I want it running on CloudStack. OK, now it's my CloudStack cluster. I need specific things that are specific to CloudStack, right? Like the zone, the network, the endpoint. OK, here's my infrastructure specific details. I want it running in this zone. I want this to be the underlying network. I want this to be the public IP, which is used as a control plane endpoint. There are more details, and we'll get into those later. All right, so before we go into how it actually works, here are a few concepts. So you have a management cluster. So you guys have seen Inception, right? Dream within a dream. This Kubernetes managing Kubernetes. So you have your management Kubernetes cluster. And what this does is it manages the lifecycle of all your workload clusters. And on it, run all your CAPI components. Your CAPI, your providers that interact with your infrastructure, they all reside on your management cluster. And they store the resources and the state. Like let's say you want 3 clusters running on CloudStack, 2 on AWS. It stores those details as well as the state, whether it's running, whether it's scaling up. Its state is also stored. And the good thing about your management cluster is it can run anywhere. It can run on any cloud. It can even run on your laptop. All right, now that we're done with the management cluster, over to the workload cluster. So the workload cluster is the cluster which is created and managed by your management cluster. It runs on the infrastructure you have specified, and it's the one that you expose to your end users. If anyone wants a Kubernetes cluster, you create your workload cluster and you expose this workload cluster to your teams, to whoever wants it. Then you have your infrastructure provider. So your infrastructure provider is what your management cluster uses to talk to your infra. It's the interface to your underlying infra. And it runs as a pod on your management cluster. And finally, you have your CRDs, or custom resource definitions. So you know the Kubernetes API, right? These are extensions. It's built on top of that, where you define your infrastructure-specific components. You want a CloudStack cluster. You want an AWS cluster. You define your infra-specific components and all the infra-specific details that would be required to create your cluster in this. All right, so let's look at how it works. So the first thing you have is you have any Kubernetes cluster, runs wherever you want. You do a cluster CTL init. What it will do is it will initialize your cluster and bootstrap it into becoming a management cluster that has all your CAPI components running on it. Then, now you have your management cluster. Great. You run cluster CTL generate. So what does this do? This generates the spec for your cluster. You can say, hey, generate it with this infrastructure. It'll generate the spec. Now that you have your spec, you tell, hey, you know what, management cluster? This is what I want. Go ahead. So you do a kubectl apply. It reads it. It understands, hey, this guy wants a cluster, let's say running on AWS. It says, hey, he wants an AWS cluster based on this cluster definition. Let me talk to AWS and bring it up. Oh, he wants a CloudStack cluster based on this definition. I'm smart enough to do that. I'll talk to CloudStack and get it up and running. And once you have all these clusters up and running, it'll also provide you the kube config, which you can use, and you can give that to your teams, and they can use the cluster however they like. And then it also provides, like we said, a single pane of glass for managing it, right? You have your cluster CTL describe, and it'll describe your clusters as well as the state they are in, their health, all of that. All right, so let's look at how it works on CloudStack. So you have your cluster definition, and you have your management cluster with CloudStack as its provider. You say, hey, this is what I want, and you also have your prerequisite template with all your Kubernetes baked in. So this is one of the requirements. You'd need a template with Kubernetes baked in. It has your kubectl, kubeadm, all your images that are required to bring up your cluster. So you have it all baked into this template. You say, hey, you know what? I want a cluster. So what does it do? First step it does is it talks to CloudStack, and it creates all the underlying infrastructure which is required for your cluster. It'll bring up the network, as well as the public IP, because you need a public IP in order to interface with your cluster. So it brings up the network and the public IP. Once that's done, it'll bring up your first management cluster, first control plane node. So it'll bring up the control plane node, and it'll add a load balancer rule to it. And then depending on the number of control plane nodes you have, it'll keep adding it to the load balancer rule. So you have your first control plane node. Once it's up and running, once it realizes it's healthy, it'll bring up the rest of your nodes. And how will it do that? It'll deploy your VM based on this template, uses the magic of user data powered by Cloud Init to bootstrap your ordinary common VM into a Kubernetes node, which will in turn join the cluster. All right, so what are the main features of CAPC? Why is it that something you would want to use? Why is it something that's actually gaining traction in the Kubernetes community and has over 10 providers? So it's customizable. It just brings up a bare-bone cluster for you to use. You can deploy your CNI, your network provider, your CSI, whatever you want, you can deploy. It's unopinionated. Then it provides a unified way to manage all your Kubernetes cluster across your infra. It's cross-platform, provides commonality, and for CloudStack, it has certain specialized features. It has affinity. Let's say you want HA. You don't want all your control plane nodes running on the same host, right? You can have your host anti-affinity. It can deploy your control plane nodes across zones. So you want even higher level of fault tolerance, it's cross-zone. Let's say you want additional disk. You're running MySQL, you need a disk on which you host your data. You can bring up an additional disk also. It has custom health checks. So let's say you would like to define how a node is considered healthy rather than the default way. You can define your own health check. Finally, you can add VM details as well. And it's an independent product. It's an independent plugin to CloudStack. So its release is independent of CloudStack's release. And if you want, you can use that and you can build on top of CAPC whatever tool you'd like. All right, back to why we did it. So this was a collaboration between AWS and ShapeBlue. And we were curious, hey, this is a nice product. This is something that we think customers would really use. This is something that the entire community can benefit from. Okay, it's a nice idea. So what did we do? First thing we did was we tried, just like any other engineer, we had a hackathon kind of thing. Over a weekend, we just decided, hey, let's just hack our way through this. Let's see whether it actually works, whether it's something that can be integrated with CloudStack. So over a weekend, we realized, hey, you know what? It seems possible. Great. So then what did we do? We had a little hacky project. We created a working prototype, something that works kind of, good enough to show off. And then now that we had a prototype, we wanted to see, okay, we have a prototype, we have something that works. But what? Is this something that a customer would really use? Is this something someone would really use? Okay, let's talk to them. Okay, maybe they have certain requirements that we hadn't thought of. Like one of the requirements were host anti-affinity, cross-zone control plane nodes. So we interacted with people who could potentially use CAPC and get to know and get their information, their input on the direction we would like to go. Since they are the users, we're just developers, you can build whatever you want, open source it. Yeah, that's great, but there's no point of doing that if nobody actually uses it. So we spoke to people who would use it, got their input, and then decided, okay, these are the features that we would like. And how did we go about that? We went in a lean and agile approach. We didn't say, hey, you guys, you know what, today we wrote 200 lines of code. That's great. Nobody cares, right? People care about what you can deliver. So we started small, and we incrementally built up on what we did. All right, so this is how we actually began developing it. The first thing we did was we just wanted code functionality. We just want to bring up a cluster. We want to bring it up, and we want to delete it. We don't care about other operations. Is it something that's feasible? Okay, great. It's feasible. Let's try a little more functionality. Can you scale it? Can you upgrade it? Okay, yeah, that's great. We're able to do all our essential functionality. Great, we got it. Now let's get the input. What would people like? We started off with a few features and then moved on to the advanced ones. Like, hey, they wanted a multiple zones. Rather than having it based on an isolated network, perhaps a shared network also, right? Then we moved on. Okay, what is something else that people would want? Oh, they have affinity. Okay, maybe they want anti-affinity. They want their HA. And they want VM details. They want to know that this VM has certain specifications, certain things that would be available to the end user for automation rather than just the VM name. And then also, yeah, custom health checks. Sure, Kubernetes provides a way through which you could know whether your cluster is healthy, your VM is healthy, but maybe we have certain services running on it that we would also like to know are up and running. So we could, let's say, expose an endpoint that you can hit, and then you'd know the state of your VM. And then finally, when we had all of this done, it was also integrated as part of EKSA. So you guys saw the presentation yesterday, right? So CAPC is used by EKSA to deploy whatever you want on your CloudStack environment. All right, so now that we developed it, this is the real fun part, right? Networking and interacting with people of the Kubernetes community. So what did we do? The first thing we did was, don't stumble about like blind idiots, right? Do your research. So you went, we looked up. They had incredible documentation on CAPI, how to develop it, how to donate it, how to open source it. They had really good information on this. So we did our research. We went through the documentation. We even spoke to a few people in the community. So great, now that we've interacted with the community, we've done our basic homework, we saw, hey, you know what? CAPC has a meeting that happens every week. Why don't we attend that meeting? That would be a good idea. That would be a good way for us to introduce ourselves, introduce the idea that we have, and then maybe we could build support around that idea. We could say, hey, this is the idea that we have. This is something that we could use, that we could see users using, customers using in their environment, and would provide a lot of benefit to them. And we built support around our idea, spoke to people, we told them this is it, and we actually built support around it. So now that we've done our research, we built support around it, it was time for us to pitch our idea. So during one of the meetings, we pitched our idea of CAPC, Kubernetes Provider for CloudStack. We pitched our idea, we had a little demo, I like to believe that they liked it, which is why we proposed it, and it was accepted that this was a great idea. This is something that was welcome in their community. And the bonus of all of this was we got to meet really great people who are members of the Kubernetes community, who are out there, who are willing to help you, who are there to guide you, even through the dumbest questions that you have. There's a great community. All right, so now that we developed CAPI, what we needed to do was we needed to integrate it, right? There's no point in having a provider if it's not integrated into the wider product, as well as image builder. So let me get into what image builder is. So you know those predefined templates that you have, right? With Kubernetes baked in and all of that. So that is generated via the Kubernetes SIG project called image builder. So what it does is you specify your base OS, let that OS be Ubuntu or RHEL or whatever you'd like, and it brings up a VM via Packer. It runs your Ansible scripts on it to configure it to provide all the containers that you need, all the container images that you need, all the Kubernetes binaries that you need to bootstrap that VM into becoming a Kubernetes node. So we integrated it with image builder and said, hey guys, you know what? We are coming up with this, and let's say they had support only, I think, for CentOS and Ubuntu 18. And what we did was we added support for Enterprise Linux 8, Enterprise Linux 7, and Ubuntu 20. We added support for all of that into image builder. And it's not something that's CloudStack specific. It's something that anyone who's running KVM can use. So we got it in there, and we wanted to integrate it into Cluster API. But oh no, they want to say, hey, you guys, you have a nice product, but are you actually seriously committed to our community? So there were certain requirements for us to meet in order to integrate it with CAPI. So what were those? So you had to be a member of the community. So how do you prove that you're a member? How do you get to be a member of the community? You have to show commitment, right? So we actually had quite a few contributions in that community, especially through Image Builder and the Kubernetes Autoscaler for CloudStack, which we had developed prior to this. So we leveraged our contributions to the community and became members. And in order to become members, we had to get sponsored by 2 existing members of the community. So when we pitched our ideas, when we spoke to people in the community, they were quite excited about the idea, and they decided to sponsor us. So we have 2 members of the CloudStack community who are members of the Kubernetes SIG, and through that, we were able to integrate CAPC into CAPI and into Image Builder. All right, so now that we've got it, it's integrated. Now we need to take it to fruition, right? The final step. So what we did, we had a repo, but we needed to open source it. We needed to donate it. So it was there in another repository. We needed to be a part of the Kubernetes SIG repository, since that's where all CAPI related stuff lies. So we were able to donate it, and I think it was pretty much a smooth process. We had to donate it to a purgatory repository, and from there it was migrated to the Kubernetes SIG repository. It was a pretty smooth thing, which took just a few hours. Next, CAPI runs as a pod, right? So what is a pod? It's a running container. So we needed a container registry where we can host all our CAPI images. So we had to create a container registry in GCR. We also had to create buckets in Google Cloud, which not only hosts our container images, but also all the manifests, all the relevant details to CAPC. So we had to create the repository as well as upload all our artifacts and completely automate the entire process so that anyone who's a member of the community can go ahead and cut a release. Then, now that the repo is donated, we need to integrate it, right, with all the integrations. Let's say our GitHub Actions to run tests, our Proud jobs in order to build our container images and publish them, and a whole bunch of other integrations. We had to integrate it. Then finally, once we were done with that, we also had to have the documentation. There's no point in a great product if the documentation is rubbish. So we had to create our documentation. We had to get a DNS record. We had to get our own website for CAPC. And once we had created our documentation, it was all ready. It was completely integrated into the Kubernetes SIG community. All right, so we saw a wonderful love story of how it worked, right? So now how is it going? So as of, I think, a month back, 20 days back, we have an 0.4.8 release. Then we have a release which people are using in their environments to deploy CAPC clusters. Next, it's been integrated in EKS-A. It has 80% test coverage, which I'm sure is a dream of any developer over here, to have such good test coverage. And finally, it wasn't just CAPC that came out a winner in this. Image Builder also was, we contributed to Image Builder and helped build it up as well. We added EL8 support, Ubuntu, I think 20 support, as well as SUSE. We've reviewed PRs for SUSE and pretty much approved it. We tested it on our infra and approved it that, hey, you know what, SUSE could also be the base OS for a Kubernetes node. All right, so what did we learn from all of this? First step is be curious. People say curiosity killed the cat, but satisfaction brought it back. Be curious, be interested, be eager, be ready to learn. There's a whole world out there. Next is ask questions. We asked the dumbest of questions to the people, and they were pretty nice. They were nicer than I expected. I like to think nicer than I actually am. And it's pretty much because everyone loves to be a hero. Like when my sister comes to me and she asks me to open a jar and I'm able to open it, I feel like Thor, like a real superhero right there. And I think everyone loves that feeling. And do your research. Avoid any surprises. So we had a few surprises along our way. Like let's say the repo donation. There were additional steps that needed to be done. So do your old research. Go through exactly what needs to be done so you don't have any surprises and you can do things much sooner. And finally, community is always greater than code. If you have a good community, you have a good product. It was a win for CloudStack, it was a win for Kubernetes, and it was a win for anyone who uses CAPC, for all our end users. All right, yeah, and this is more fun stuff that happened. So I was able to go to KubeCon, and I met Michael Elmico, and he was one of our sponsors, one of the guys who sponsored our membership into the Kubernetes community. And I also met Vipin, I'm sure the guy who gave the presentation about EKSA yesterday. I was able to meet him as well at KubeCon. So it wasn't just we developed a product, we got a network, we got a network, and we had a great time at KubeCon as well. And now, what about the future? So we have a great product. What are we looking for towards the future? So you want unmanaged clusters in CloudStack. So great, we have CAPI, but CloudStack isn't aware of them. To CloudStack, they're just a bunch of VMs. So maybe functionality in the future to make CloudStack aware of these clusters, but as unmanaged clusters. Still managed outside, but CloudStack knows, okay, these exist. Next, additional OS and Kubernetes version support in Image Builder. And finally, yeah, a lot more, just wait. All right, and not just that. So now that we have this great thing, there's just a few of us, but we want you, we need you. So go ahead to our repo, use the product, raise issues, raise PRs. It's a welcoming community. There's a Slack channel if you have queries, if you have doubts, or if you just like to talk to us and say, hi, thank you, we love what you've done. That will also pretty much flatter us. We have documentation over here that you can use, through which you can get to know about our product. And finally, we have a YouTube channel with tutorials on how to get started with CAPI. All right, time for a demo. Let's hope it works. OK, so what I'm going to do is I'm going to use a kind cluster. So like I mentioned, kind is nothing but Kubernetes and Docker. So all you have to do is just bring up a kind cluster. It brings up a kind cluster. So it gets everything you need. And now you create your credentials. Your credential is nothing but your URL, your secret key, and your API key. You apply it, and now you have your kind cluster, and you want to bootstrap it into your management cluster. So use cluster.ctl init, specify the infrastructure as CloudStack, and it'll bring up all the components you need to bootstrap your ordinary common cluster that's running on your local laptop into a management cluster. All right, so now let's have a look at what we would need to do to get this started. So you have your kind cluster, you've created it, you initialized it. So let's go ahead. So I'm just going to create these environment variables which specify CloudStack specific components. Your network, your endpoint, your template, the VM that you would like to use, the control plane node, the offerings. And now you saw the scary YAML, right? Let's go ahead and create it. And it's just a simple command. You've already specified your environment variables, and now you'd like to generate a CAPC cluster. What does it do? You specify your Kubernetes version, your control plane count, and your worker machine count. And let's open it up. And it's generated all the confusing, scary YAML for you. It's gone to CloudStack. It's added the zone name, the network name, as well as all your VMs. It's set the Kubernetes version for you. It says which template you would like to use, which offering you'd like to use. It's generated all that scary YAML for you. And now that you've done that, let's just go ahead and apply it, just like you would apply any Kubernetes manifest. So as a command for that, okay, let's just. All right, so it's going to talk to CloudStack and create all the resources required. If we have a look, there are no instances, and there's no network. OK, it's just created the network. All right, so this would take a couple of minutes, so I'm open to questions meanwhile. Yes, it can. OK, so just to repeat the question, can it be deployed on an existing network? Yes, it can. If the network doesn't exist, it'll create an isolated network with that name. And yeah, it supports isolated as well as shared networks. But if it's a shared network, it needs to be a pre-existing network. As of now, VPC tier is not supported since I think firewall or load balancing or something isn't supported in a VPC tier. So we could look into that as a future enhancement.
OK, thank you. So this mic isn't working, so any further questions from the room? Got a few minutes?
OK, I think that this is taking a bit too long. Let's just go to a little video where you see it up and running. So blah, blah. OK, let's just check its status. OK, so it's coming up. You can see that the control plane nodes are 0. It's bringing it up to 1 replica, and the worker nodes are coming up. All right, meanwhile, any questions?
Anybody? We've got a couple minutes.
OK, great. I can go into the demo a bit. Let's look at it. All right, so you can see that it's waiting for the infra. It creates the first control plane node. It creates the public IP, which is used as the control plane endpoint through which you can run your kubectl commands. Blah, blah. It creates the load balancing rule. So if you have multiple control plane nodes, it'll create the load balancing rule for you. And yeah, once they're up, it shows that it's ready. It's true. And you can see that your control plane node has come up. You go ahead and apply whatever CNI you want. Once the CNI is deployed, your nodes from not ready will become ready. And then you should be able to see that your nodes are ready. And then finally, it says that your entire cluster is up and running and ready to use. And then let's see, did I do any? Yeah, and then you can use that. You run your kubectl command just to curl to make sure it's working. Dummy app just to make people happy. And there you go. you have a fully functional working Kubernetes cluster that's ready to use, that's deployable in a few minutes.
Thank you, David. Any questions for David at all? We've got 30 seconds. Perfect timing, David. Anything? Okay, brilliant. David, thank you very much.
All right, thanks, guys.